Pesticides, by their nature, are designed to kill insects. Unfortunately, this means that pollinators such as your standard honeybee or butterfly tend to get caught in the crossfire, especially with neonicotinoids. In other words, neonicotinoids are a class of neuroactive chemicals that are used in the treatment of crops. These chemicals, such as the most commonly used one, imidacloprid, are absorbed by the plants they're being used on, thus becoming present in all of the tissues of that plant. This disrupts the pollinator's homing abilities, foraging abilities, and also weakens their immune system by disrupting larval development. Eventually, the insect is paralyzed and dies. This problem could be solved if people could tell how long or where neonicotinoids might be, but there's little data showing the locations of where these pesticides might accumulate in, and they also have the potential to last for many years in the soil. Pollinators typically have little to no resistance to pesticides, so they're the ones that are hit the hardest by them. In addition, pests will gain resistance to these pesticides, thus breeding stronger pests for future generations. So not only are pollinators harmed by a lack of knowledge of pesticides, but stronger generations of pests could also form as a result of excessive pesticide application. It could be a vicious cycle. The use of too many pesticides will lead to the deaths of many pollinators, which in turn will decrease the amount of food people can have. Eventually, there will not be enough food to feed most people as a result of pollinator deaths. Food prices will skyrocket due to food shortages for what is left. Following principles of pesticide and integrated pesticide management, which considers the economic ends of things, possible solutions include the creation of test strips to measure the amount of pesticides in an area, or even something as simple as using less pesticides. Despite popular beliefs, it is not too late to make a lasting change to benefit our world.